We'll work on the next notebook, Notebook 8, learning about web APIs. This is one of the most important concepts when you start working with geospatial analysis. When you take a beginner course, it's unlikely that they will teach you about web APIs because this is an advanced concept. But since we are learning geospatial analysis using Python, this is a topic that will score to so many types of analysis that we must cover it. So it's an advanced topic, but I'll try to make it more approachable. When we installed some third-party modules and we were able to use the functions, remember we installed GeoPy and we were able to call a function from GeoPy's module. That function was running from our computer. So we installed it on our computer. When we called that function, the third-party module ran that function, which was on our computer, and it ran that computation on our computer. This kind of setup works where you can have code that can be run on a computer. You don't need too much data for your analysis to run, so you can download all the data to your computer and do this. For many of the spatial problems, this is not possible. Most of the data sets that we want to work with are fairly large. So if you want to run some computation, you'll have to download all the data to your computer, which may not always be possible. Also, a lot of the computation will require very large computation resources, which are also not optimal to install and use your local machine. So over time, what people have done is, instead of having a package that runs on your system, they say, can we build a system where we run a server, we install all the required stuff on a server, we have all the data that you need, and you can just call the function on our server. And we have all the data, we have a very powerful server. You can call, we'll run the function on our server and just return the result. This is the concept behind an API. So API stands for Application Programming Interface. So it's a fancy way of saying, how can you run a function on somebody else's computer? It allows you to run a function in another system using this method. We are specifically learning about web APIs. So how can you use internet to call a function on somebody else's computer? So in geospatial analysis, web APIs are used for things like getting directions. All of you must have used Google Maps. What if you wanted to compute distances between 1,000 addresses? You can use a web API that Google Maps provides and say, give me all the distances. I can, you have all the data, you have all the computation. I'll just tell you my addresses, you compute the distance, and you can return the result to me. So that's one of the web APIs that Google offers. Similarly, you have other APIs of things like, I want to download some data, I want to do some route optimization, and I need a lot of data for that, but I can just send you my data, what I have. You do the analysis, you send me the result. You want to get some weather data from some place. I don't want to run a weather model in my system, but if somebody has done this, I can call that server and get the result. So you can see a lot of the problems that we want to solve using geospatial analysis are accessible using web APIs. So how do we run it? Well, how do we communicate with the server that is running on somebody's system? That server may not even run Python. That server might be running Java or C++ or any other programming language. So over time, people have agreed to say we can communicate between two machines, from your machine to a server, using a standard language. And that language is known as REST API. So we're going to learn about the REST API, which is used to communicate between two machines on the internet. The language that the REST API uses is this language called JSON. So JSON stands for JavaScript Object Notation. This is a language in which you describe your request. So if you say, I have a server, I want to ask server to do some computation. The server may not understand Python, server may not understand Java, but if I can describe my request as a JSON object, the server will understand that. And the server will say, I've computed, I want to send you the result. In what format should I send the result? Again, the server will send you the result in JSON. So once we understand the JSON format, we'll be able to communicate with any server on the internet that understands this REST API. There's an extension to JSON called GeoJSON, which supports describing geographic objects like latitude, longitude, polygons, etc. So when we're doing geospatial analysis, you call a server that is doing some geospatial analysis, might likely send you back a GeoJSON. And you need to use this in your program. So let's learn a little bit. You don't need to kind of learn this in detail. I just want to introduce what is the communication language between your computer when you're writing your code and the server that is doing the analysis. GeoJSON is very similar. It looks very similar to Python, right? You can say this is a GeoJSON string. You can see I'm creating a triple quoted string. And if you wanted to kind of get some data about San Francisco, and the server says, oh, I'll give you weather, real-time weather of San Francisco. Just send me the name of the place and the coordinate. Now, how do I send the request in the JSON format so that I can say, these are the coordinates, this is the name. So this is the format. I'll take my data and I'll create a string that looks like this, where it says the name of the place is San Francisco. The geometry is this point with this coordinates. And once this request goes, the server would understand, oh, I understand JSON. You'll take this, it'll give you the weather information. It'll send you back the data in GeoJSON. Okay, so you need to take this and read the value and extract that. So conversion from your Python data to GeoJSON and GeoJSON to a Python data is a very common operation that you need to do. Most programming languages, including Python, will have a built-in way to convert JSON to Python objects. So you can see I have this GeoJSON string, which is just a text that I have created in Python. I want to convert this into a Python object so I can extract certain values. I can use the built-in module called JSON. This is part of the Python standard library. And I can say JSON.loads GeoJSON string. This function will take a string, convert it into a Python dictionary. So if I say, what is the type of this GeoJSON string? You can see it's a string. Once I convert it using the JSON module, you'll see that my data becomes a dictionary. So my data becomes a dictionary. So I took a string, which is a very complex looking thing. The built-in JSON module will take any valid JSON text and convert it to a dictionary. And once we have a dictionary, you can just extract stuff. You can say this is a dictionary with two keys, type and features. The features is a list, and this one is another dictionary, and so on. So I can go and extract the parts I want from the string. So this kind of conversion can be done using the JSON module. And again, we can run some code to extract the data that came as a string. You won't have to do this manually. Python has now packages that do this internally automatically, but there are still instances where many times you're working with the web APIs, you would get something that's a JSON and you want to turn this into a pandas data frame or Python object. You would remember there's a module called JSON that will help you convert between those two. Questions on web APIs and JSON module before we move on to our analysis. So for the longest time, if you're working with web APIs in Python, you had to use modules such as URLlib, URLlib2, etc. They were quite painful to work with. And this is what I had used from all my professional life. And it was quite painful to work with web APIs. Over time, there was a new module that was developed called requests. This is now part of the standard library of Python, which makes very easy to work with the web API. So that's what we'll be using. Request module, again, it can call any URL or any web service, and you can get the data from that server. You can do this not only for Geospatial, but for any website. So for example, if you want to check whether a certain website is working or not, you can use the request module and say request.get and get the URL of a website. So I'll send the request and say, get me, call this website using Python and tell me what the website says. When you call a website, the website will first say any server that understands JSON will say, I got a request, and it'll respond with a code. And these are the HTTP codes that you need to understand. So the HTTP codes will be in form of some numbers. So if you call a server and the server says 200, that means the server understood your request and you got it, give you the correct response. So if you get a response 200, that is okay. Yeah, I understood your request and I got things back. If you got something that starts with 4, that is an error. If there's an error, you'll get stuff starting with 4. So when you work in the APIs, when you call an API, the first thing you check is what's the status code. If the server returned 200, that means all is good. It understood the request, it sent you the request back. If you get something else, that means there was an error. Even a simple thing like this can be very helpful. I remember a task where somebody I was working with said, I have a list of 10,000 websites. I want to check which websites are valid or not. Can you help? And I just wrote a for loop saying, go through all of this, just check the request to get of the URL, check the response code. 5 minutes later, I had a spreadsheet with all the websites that were down. And so again, those kind of things you can automate by using the request module. Now we're going to solve this problem using a website called Open.Service. Open.Service is a project that offers you some routing APIs based on the OpenStreetMap data. It's one of my favorite APIs to work with when I'm working with any network analysis task. This is a university project where they offer the service free of cost. Every day they take the latest OpenStreetMap database and build a routing model, which is accessible to everybody. I'd asked all of you to sign up for an API key. So you signed up, you have an account, and if you come here, you can see this is a free service. Again, because it's an open server on the internet, you don't just keep it open, people might abuse it. So they offer the service, you still need to sign up, get an API key that identifies your account, and they offer a standard plan where you can use a server with certain limitations. So you can say you can call this server 2,000 times a day. And you can do this, use the service free of cost. If you want more things, they say, I want to do all this server 10,000 times a day. Well, you can just download their service, run the server locally on a machine, and you can use it as many times as you want. So you can, it's an open source project, so you can run it locally as well. They give you instructions on how to do this locally if you wanted to. But we're going to use the web version, which they offer free of cost. The Open.Service offers services that can do many things. Things like directions. Given two coordinates, it'll give you the turn-by-turn direction between those 2 points. And all you need to do is call that URL with those parameters, and you get the turn-by-turn directions back. You also get isochrones. So you can say how far I can travel from this point in 30 minutes, and it'll give you a polygon for that. It gives you distance matrix. You can say I have 10,000 origins, 10,000 destinations. Give me the time from each origin to each destination. Instead of doing this 10,000 times different calls, you can just do it one time. This is widely used by logistics companies where they want to say, I have all these packages I want to deliver. They are the warehouse, these are the addresses, which warehouse will deliver to which address, and so on. Right? You can use this kind of distance matrix. It has got other APIs of things like elevation. Given a coordinate, what is the elevation? It also has this another service called optimization. I want to visit 5 addresses. What is the most optimal path? Or I have 10 vehicles, each vehicle can carry 5 tons of waste. They need to pick up waste from 100 different addresses. Which vehicle should go to what address in what order? Like those kind of things they offer as a service. You can describe your request and you will get the response back. So really useful things. A lot of people use this in their class project as well as the real projects, and you can do some interesting things with it. We'll use this API. We'll learn how to use this API to compute distance between the 2 cities that we selected, and we'll use the directions API to compute the distance. Okay, so first step, we had to sign up for an account for Open Map Service. I have signed up. You go to a dashboard and you get this API key. The API keys are required so that it identifies you and it can enforce the limits. So here we replace it with our key. So this is a long number that uniquely identifies you. So once I have saved this, this variable ORS API key will now refer to this API key. Okay? So I can just use that variable instead of my API key. So our idea is we want to use the Open.Service to compute the distance between 2 cities. Let's see which service we can use. So come to the Open.Service website. From the main website, we can go to this API playground. These are the different APIs offered by this server. We can go to the direction service. Here we have this documentation here. If I click here, it says, this is how you call the direction service. This is the URL. You call this URL api.open.service.org, v2 directions driving car. It takes 3 parameters. You can see you need 3 parameters. Give your API key, give your start coordinates, give your end coordinates. And you'll get the route between those 2 points along the road network. If you hover over this, you can see I want the coordinates in the longitude, latitude format as a text. So again, every service will expect coordinates in different order. Read the documentation. It says, give me the coordinates of a start and end location in longitude and latitude format. So let's call this and see what happens. So we need to call this URL with these 3 parameters. We are using the request library. Request library allows us to call any URL with the different parameters using this format. So we can define our parameters as a dictionary. There are 3 parameters required for this particular service. We need our API key, start and end location. API key we have saved in this variable. Start will create this string using the format function. Remember, the format is longitude, latitude. So we'll take the second value and first value, create a string. And same with the end. Once we have the parameters, we can say request.get, call this URL. This is the same URL that is specified in the documentation. We're calling this URL, and we can specify the parameters as the params value here. And when we call this, our request will go to the server will process it and send us the data back. Every time we call this, the first thing to check is, was our request successful or not? So I'm going to run this cell, and you can see I get the answer, request successful. That means my server understood what I mean by sending this request, and it gave me the answer. If there's a problem here, either you do not have the correct key, or the key has expired, or you gave the start and end points in wrong format, you would get an error. So once we get this, we can check if the request was successful. Let's get the data as a JSON object directly. So server has got the data. We can call response.json, and that will convert the JSON object into a Python dictionary. So let's just see what we got. I'm just going to print what the server said, and this is what the server sent us back. So you can see the server sent us all this data. It's a very long data that the server sent us. And what did the server send us? Server said, you asked me for directions between San Francisco and New York. Here are directions. So you can say the distance is this much. This is the total duration, and these are the steps. So it gave me a turn-by-turn direction all the way from San Francisco to New York. So start here, head northeast on Market Street, turn right on 10th Street, and so on, right? You have the full address as a Python dictionary. So if you wanted to build your own navigation app, for example, you can use the API and say, enter address, and now you can display this turn-by-turn addresses on your app. So now you have this as a Python thing, you can do something with it. We are currently not interested in the turn-by-turn direction. What we're interested is in the distance. Remember, the API said the driving distance between those is here. We have the distance and the duration along by traveling in a car on the OpenStreetMap network. We asked for a car direction. So let's extract those parts and see what it is. So we extract that part. Now there's a summary key, and we have these 2 values. This is the distance and duration. If you read the documentation, it says open out service will tell you the distance in meters and duration in seconds. So let's see the distance. We convert this into kilometers and says the distance between San Francisco and New York is 4692 kilometers. Compare that with our previous result. It was 4145 kilometers in a straight line, 4692 kilometers if you actually took the road. And this is along the actual highways based on all the turn restrictions and the things. So you get the exact driving distance between those 2 cities. So here, if you want to change the driving mode, you can come to the documentation. And if you see the path parameters, you can see they have different profiles you can ask. So you can say, I don't want the driving distance. Maybe I like to go on a cycle trip between the 2 cities. So I can say, give me a cycling directions. If I want cycling direction, you can see the URL changes now. Instead of driving distance, we can say direction/cycling regular. And again, you can call the service with this URL, you will get the cycling distance. And this distance might be more or less because certain roads may allow bicycles, certain roads may not allow. So if the data is in OpenStreetMap, you will get the distance which is different between car and this thing. Similarly, they have profiles for, say, trucks, HGB. So certain roads have restrictions on trucks. If you want the trucking direction, you can call this URL. Let's do the next part. Let's learn about this term called rate limiting. Let's open up the opened out service website. It's a free service, but as we saw earlier, it comes with some restrictions. If you sign up for an API key, the free API key says you can use the service free of cost as long as you are not calling it more than 2,000 times a day. You can get up to 2,000 directions a day. So we can do that. We can say, okay, I will not call this service more than 2,000 times a day. But it also has one more restrictions. It says you cannot call the service more than 40 times a minute. So you can call it maximum 40 times a minute up to 2,000 times a day. That's a rate limit. And again, these restrictions are there because if you have a program, you can make the program go as fast as you can. You can say, I have 10,000 addresses, let me send all of them at once. And the server will get overwhelmed. So they'll put a restriction saying that each API key can only call me 40 times a minute. So all services, including any commercial service you sign up for, they'll have a rate limit because they don't want you to send the request too fast. So we can enforce this daily limit ourselves, but how do we enforce this 40 requests a minute limit? So let's learn about rate limiting. If you have let's say I have 100 addresses which I want to get the distance from. If you write a for loop, I say I have a file containing 100 pairs of addresses I want to get distance. You say for X in each address, call the service. And you can see it just happened. My for loop ran very fast. And it'll send all these 100 requests together to the open route service. And open service will say, error, too fast. You're sending the request too fast. So when you're writing your for loops, you cannot write it just the way you write because your program will run very fast. So Python provides a very simple mechanism. There's a built-in module called time. You can say import time, and in the loop, you can say print x and then say time.sleep 2. That means after print x, sleep for 2 seconds. So pause for 2 seconds, and then it'll go to the next line and see what happens here. So you can see now my loop is running quite slow. It's pausing 2 seconds after each request. And this ensures that if I'm pausing 2 seconds between each request, at most I can send only 30 requests in a minute. So if I write my for loop with time.sleep2 between them, I'll comply with the rate limit. Many APIs will also offer their own way of rate limiting. There are other modules in Python which are more advanced, but I find that for most simple use cases, just the time module, time.sleep, is more than sufficient. So the idea is if you are calling the service in a loop, make sure you add a time.sleep between them so that you're not sending the request too fast and your server doesn't reject them. My loop is still running. If you want to cancel the loop, you can go to kernel, interrupt kernel. That is the command in Jupyter Lab to stop any cell from running. So you can interrupt and stop that.